Okay, so this first one here, we're multiplying fractions, but I added the units into it. So what we have to deal with is we're going to cross cancel, but not just with the numbers, also with the units. So here, the 8 and the 150 can both be divided by 2 to give me 4 and 75. But the milliliters can also cross cancel out. 4 times 200 milligrams is 800 milligrams. 1 minute times 75 is 75 minutes. And now typically in a rate like this, in a fraction like this, we would convert it down to what we call a unit rate. So we would make the denominator equal to 1. So we divide by 75 to get rid of the numerical portion. So that's now 1 minute in the denominator. 800 divided by 75 is going to give us a little bit of an ugly number. So 10 2/3 milligrams per minute. So similar type of thing down here. Milliliters will cross cancel out again. Numerically, there's nothing that's going to cancel out, so we're just going to do the 4 times 12 is 48. GTT is an abbreviation for drops. 1 minute times 1 is 1 minute. So that becomes 48 drops per minute. Here we've got 20 milligrams over 1 minute times 4 milliliters over 5 milligrams. And again, the milligrams can cross cancel. Numerically, we've got 20 and 5. They can both be divided by 5. 5 divided by 1, or 5 divided by 5 is 1. 20 divided by 5 is 4. So 4 times 4 milliliters is 16 milliliters. 1 minute times 1 is 1 minute. So there's 16 milliliters per minute. What we've done here is simply following the rules of fractions and that cross-canceling. But when we do it with the units, it's referred to as dimensional analysis. We're going to look at dimensional analysis a lot more in our next unit when we're dealing with converting units. And also, it's going to be one of the strategies we use for doing our dosage calculations when we get into Unit 3. So it is a huge skill to have. I know a lot of people don't like working with the fractions, but being able to work with the fractions and cross-cancel and line up the units so they cancel is a big skill for medical fields. Okay, before we get too far into it, just a reminder, next week, during the first hour, is going to be our first unit test. I do allow unlimited time for the test, so if you need more time, you can take it. It's just at 9:30, I will ask that you come back into the classroom or put the test aside, and we will start our lecture for your Unit 2 material. So you can have more time if you need it. I'll just have to have you come back after class or arrange some other time to finish up if you need more than an hour on the test. There is the first half of the test is no calculator. The second half, of course, you can use your calculator. On the whole test, you may use your notes and your books. So make sure if you've got notes that you need to organize a little bit so it's easier for you to use, you do have that there for you so that you can use. And on the first half, as I said if you want to use your calculator to double check your answers, you can. It's just to get credit for the first half, you have to show your work. Yeah. How many questions is the test going to be? Good question. Okay, so the first portion where you cannot use your calculator is 15 questions. And it looks like there is a total of 31 questions on the test. But a lot of them go pretty quickly. So a lot of students are done in about 30 or 35 minutes on this first test. Any other questions? Okay. I apologize for my voice and for coughing in your ear a lot here today. I don't feel nearly as bad as I sound, I assure you. Where we want to start out today is we want to start out dealing with some more problems like this. Where we have more than one thing going on. When you look at a problem like that, there are a lot of different ways you can interpret it. You could think of, oh, well, maybe we'll just go left to right, like reading a book. And maybe do the 8 minus 2 first. And just keep going. But that would not be correct. If we were to do that, and don't write this down because it's going to be the wrong answer. 8 minus 2 would be 6. Well, then 6 times 3 would be 18. Plus 7 would be 25. But that's not the right answer. Makes sense, but there's also other ways that we could do this that would make sense. So when we have two people doing a problem in math, we like to have them come up with the same answer. So to make sure they do, we've defined our order of operations. In the order of operations, a lot of people think of it as steps to solving a problem. What it really is levels of priority. And it only applies in generic problems like this where there is no context. There's no setting that the problem occurs in. If you're dealing with a story problem, there's a setting or a context that tells us what has to happen first. So order of operations only applies to these generic problems like this where it's all numbers and operations. Also, order of operations applies to your calculator. Your calculator will obey the order of operations where it can. So as you're entering stuff into the calculator, be aware that how you enter it may have effects on the answer it puts out. So the highest level of priority, the first thing you would do if it's available, is something called enclosing symbols. A lot of us were taught enclosing symbols are just parentheses. And that is the main type of enclosing symbol we'll see, but there are other types that we will run into. Second level of priority is exponents. Exponents includes two things, powers and roots. And our third level of priority is multiplication. Now we mentioned last time multiplication and division are really the same operation. So division happens along with our multiplication. And then the lowest level of priority, the last thing you would do if there is nothing else left to do, is addition. And as we mentioned, subtraction is part of addition. So subtraction goes on that level as well. So, back to our original problem we presented here. 8 minus 2 times 3 plus 7. There are no enclosing symbols. There are no exponents. So we're down to multiplication and division. And we do have 2 times 3, which is 6. So we take out the 2 times 3 and we replace it with 6. Everything else stays the same. Now I get asked a lot, is that really a 2 times 3 or is that a negative 2 times 3? And the answer to that is yes. It can be either one. I can leave it just like I have as 8 minus 2 times 3, which would give me what I got here, 8 minus 6 plus 7. Or I could change it to 8 plus a negative 2 times 3. But notice now, if I treat that as a negative 2 times 3, this is now addition and not subtraction. It's going to end up the same because it'll be 8 plus a negative 6 instead of 8 minus 6. But you can interpret it either way. So now that I've done that multiplication, all I have left is addition and subtraction. And I actually have one of each here. If I have more than one operation that's on the same level, then we do go left to right. So just like reading a book. 8 minus 6 is 2, and plus 7 is 9. So let's look at one that's just a touch more difficult than that. Let's do that. This one's a little bit long, but as long as we follow our order of operations, it's not too bad. Highest level of priority is enclosing symbols. Well, we have several sets of parentheses here. If we have more than one item on the same level, we go left to right. So going left to right, the first parenthesis we run into is this one right here. We have to find its other end. Well, this one here is facing the wrong way. That can't be it. This one here goes with that one, so that's not it. This one here must be the other end of that parenthesis. So now we're narrowing our focus down to inside that set of parentheses, or inside the blue box, if you will. Inside there, order of operations still applies. So we're still looking for more enclosing symbols. And we do have another parentheses. So we're going to narrow our focus down to that set of parentheses, or inside the brown box now. Well, inside the brown box, again, our order of operations still applies. Are there any other enclosing symbols? No. Exponents. Yeah, 4 to the power 2, or 4 squared. So that is 16. So we replace the 4 squared with 16. Nothing else changes. Now be very careful. I've found through the years there are often more mistakes made rewriting the rest of the problem than there are doing the calculations. Part of the problem is a lot of people try to take shortcuts. They try to do 2 or 3 steps at once as they're rewriting the problem. It's a lot easier. I know it's a lot of writing, but it's easier if you just do 1 step at a time, rewrite the problem, and go from there. So now we are still focusing inside this set of parentheses. There are no more exponents, so it's going to be multiplication and division. And there's one of each, so we're going to go left to right. So do the 8 times 6 first is 48. And again, nothing else changes. Still inside that set of parentheses, 48 divided by 16 is 3. Okay. Now that that parentheses is reduced to a single number inside of it, we don't need the parentheses anymore, so we can get rid of the parentheses. However, when we get rid of the parentheses, we notice there's this 3 in front, and there's nothing between them. When you have a number outside of parentheses with no symbol there, what does that imply? Multiplication. So when we take out those parentheses, we have to put in that multiplication symbol. So now that set of parentheses is gone. We're back out to this larger set of parentheses that we were in. And again, we go back up to our highest level of priority. Are there any other enclosing symbols? No. Any other exponents? No. Multiplication and division? Yes, right here. 3 times 3, which is 9. So again, the rest of the problem stays the same. So still inside that parentheses, no more multiplication or division. We're going to do addition and subtraction and go left to right. 17 minus 9 is 8. And now we have the 8 plus 3 is 11. Now, since I've reduced that to a single number, I'm going to take the parentheses out here in the same step. Do I have to put multiplication in here? Yes, I do. There is no operation there, so I do have to put in the multiplication. So now we've finished that parentheses. We're back out to the larger problem, and we have to go back to the highest level of priority again. Are there any other enclosing symbols? Yes, there's another set of parentheses. So back inside of there, no other enclosing symbols, no exponents, but we do have multiplication. 3 times 2 is 6. And then we can do the 7 minus 6 is 1. And since that parentheses is down to a single number, I'm going to take out the parentheses as well. And we do have to once more put in multiplication. Now, all the parentheses I had in this problem had a number in front of them, so we had to remember to put in that multiplication. There will be times where there's addition or subtraction in front of them, so you don't have to put that in. But the multiplication only has to go in if there is no other operation in front of that parentheses. So now there's no more enclosing symbols, no more exponents. So we're going to do our multiplication and division left to right. 2 times 11 is 22. 2 times 1 is 2. And now we're down to addition and subtraction. We're going to go left to right again. 8 plus 22 is 30. And minus 2 is 28. I know it's a lot of writing. That's probably bigger than anything I'd ever make you do on a test, but it has all the skills. And any questions on that? Now, I hesitate to point out what I'm about to point out because I don't want to put anything in your head. But I have to show you the single biggest mistake that people make on a problem like this, and I will most likely catch at least one of you doing it on the test next week, is they look at this problem and they say, oh, there's a lot to do there, but I can just do the 8 plus 2 and get 10 right away. The problem with that is, if we look at that 2, yeah, there's addition here, but there's also an operation that comes after it. That would be the multiplication. Order of operations says which of those has to happen first? The multiplication. So I cannot do that addition up front until I've done the multiplication at the back of the 2. So be very, very careful with that. I will catch, like I said, I'll catch at least one of you doing that. Every semester, I catch at least one person that does that on that problem on the test. Okay, so another type of problem, another type of enclosing symbol might look like this. To understand a problem like this, we have to understand this symbol here. What is that symbol? It means division, yes. It's called a fraction bar, and it does mean divide. We are going to divide at some point. It is also an enclosing symbol. It separates the top of the problem from the bottom. So it's telling us we have to do everything on top first, then we have to do everything on bottom. Then we have to divide. So we're going to do the top of this first. On top, are there any other enclosing symbols? No. Exponents? No. Multiplication and division? Sure is. So we're going to start left to right. 8 times 5 is 40. What's next? 32 divided by 4 is 8. And finally, 40 plus 8 is 48. So we've got 48 on top. On bottom, what has to happen first? We have our exponents. 5 squared is 25. Now notice I didn't try to do both of them at once. I'm just doing one step at a time. Now I'll do the 3 squared, which is 9. Excuse me. 25 minus 9 is 16. So the bottom is 16. And we divide. 48 divided by 16 is 3. Any questions? Okay. Well, I said there are a lot of different combinations of problems we can throw out there. We can throw fractions and decimals in there as well, but I'm going to trust that you guys can figure that out. The next step that I want to move on to is I want to start looking at just the basics of percents. We'll actually come back more in the next unit and look at percents a little bit more and go in more in depth. But we need to get the basics of them down in Unit 1. To understand the basics of percents, you have to understand the word percent. It's actually 2 words. It's per. If you think of miles per hour or miles per gallon, dollars per hour, it's for each or out of, and cent. Think of cents in a dollar or years in a century, it's 100. So if you have 84%, that literally means 84 out of 100. In fact, that percent symbol that we're used to, looks like that, comes from this symbol here, which is just a generic ratio or a blank fraction. So it really is that easy to change a percent into a fraction, just like that. Put it over 100. Now we wouldn't leave it like 84 over 100 because both of those can be divided by 4. So 84 divided by 4 would be 21. 100 divided by 4 would be 25. So that'd be 21 25ths as a fraction. We might have 340%. We need to convert that to a fraction. Again, percent means out of 100. So 340% means 340 out of 100. Now you look at that and think, well, that's bigger than 1. It's going to be a mixed number. And that's true. 100% is a whole thing. 100% is 1. So anything bigger than 100% should be bigger than 1. So I would do the mixed number first because it's easy to divide out 100. 100 goes into 340 3 times with the 40 left over. So 3 and 40 hundredths. And we can reduce that fraction. Both 40 and 100 can divide by 20. So I've got to remember the whole number, the 3. 40 divided by 20 is 2. 100 divided by 20 is 5. So 3 and 2/5. We might have 36 2/3%. To convert that into a fraction, well, percent is always out of 100, so it's 36 2/3 out of 100. There's 2 different approaches we can take for this. One is we can look at that and say, well, I want to get rid of the fraction. And to get rid of a fraction, you just multiply by its denominator. That has a denominator of 3, so I can multiply by 3 on top and bottom. Well, 36 2/3 divided by, or times 3 I'm going to make that into a fraction by making it 3 over 1. I have to make this into an improper fraction. So 36 times 3 is 108, plus 2 is 110. So that's 110 thirds times 3 over 1. Come on. Cross cancel my 3's. I get 110 over 1, or just 110. On bottom, I have 100 times 3, which is just 300. And I can reduce. Both of those can be divided by 10. Gives me 11 over 30. I think that way's a little bit tedious. This other way's a little bit easier. It's still a little tedious. But we've mentioned before, a fraction and a division problem are very closely related. You can kind of go back and forth between two of them. So 36 2/3 over 100, I can make that 36 2/3 divided by 100. So then changing the 36 2/3 into an improper fraction, that is still 110 thirds. Making the 100 a fraction by making it 100 over 1. So I'm going to multiply by the reciprocal, 1 over 100. And I can cross cancel the 10s. 110 divided by 10 is 11. 100 divided by 10 is 10. So I have 11 times 1 is 11. 3 times 10 is 30. So I get the same answer. I think this way is just slightly easier. Both of them are a little tedious. If you have a fraction calculator, this is one you can just punch into the calculator and it will spit out the fraction for you. We might have 56.25% asked to change it into a fraction. Again, it is always over 100. So 56.25% is 56.25 over 100. Now, I don't like having fraction or decimals within my fractions any more than I like having fractions within my fractions. So to get rid of that decimal, I'm going to have to multiply by something. Now, since that's 0.25, I could multiply by 4 and it would go away, but you might not see that. The easiest way to get rid of a decimal is to just go by the number of decimal places. If there's 1 decimal place, you multiply by 10 to get rid of it. If there's 2 decimal places, we multiply by 100. So I multiply the top and bottom by 100. 56.25 times 100 is 5,625. 100 times 100 is 10,000. Now the real chore here becomes reducing it. You probably see that that's both divisible by 5. You might see they're both divisible by 25. I'm going to save us a little time. They're both divisible by 625. Give us 9/16. Any questions on those? I want you guys to try a couple. 3 to be exact. I want you to try 265%. Change that into a fraction. 18 1/3% and 62.5%. Change those each into fractions in your notes. We'll discuss them in about a minute. Okay, so first one, 265%, 265 over 100. I would split that up into 2 6500ths, both of which can be divided by 5. Which gives me 2 13/20. Any questions on that one? Okay. 18 1/3% is 18 1/3 over 100. I would do 18 1/3 divided by 100. Make that 100 over 1. This is 55 thirds times 1 over 100. Cross cancel 55 and 100. Dividing by 5 gives me 20 and 11. 11 times 1 is 11. 3 times 20 is 60. So 11/60ths. Any questions on that one? Okay, then 62.5% is 62.5 over 100. Multiply top and bottom by 10 is 625 over 1,000. Those can both be reduced by 5, 25, or 125, which will give me 5/8. Anybody get all three of them right? Show of hands. Quite a few. Good deal. Okay. It's about time for a break, so let's go ahead and do that here before we go any further. It's 9:19 right now. Let's come back in at 9:29, and we'll continue from there. So their next step, we change the percents into fractions. Let's change them into decimals. So we said 84% meant 84 out of 100. And thinking of it that way as a fraction, if we want to turn it into a decimal, we're just do numerator divided by denominator. 84 divided by 100, which would be 0.84. So since percent is always out of 100, changing a percent to a decimal is always going to be dividing by 100. And when we divide by 100, the shortcut for doing that calculation is just moving the decimal point 2 spots to the left. So if we had 31%, we could just move that decimal point 2 spots to the left. As a decimal, it becomes 0.31. So I'm just going to have you guys yell out the answers for me. If I change 57% to a decimal, what does it become? 0.57. Good. If I change 240% to a decimal, what does it become? 2.4. Good. 70% to a decimal becomes 0.7. 8% as a decimal becomes 0.08. And 3.9% as a decimal becomes 0.039. And here's the one I usually catch people on. 1/4% as a decimal. There we go. 0.0025. 1/4 is 0.25, but that would still be a percent. So it changes the decimal. You still got to move the decimal point over 2 spots. One thing that I talk a lot about when I'm doing percents is benchmarks. One benchmark is 1%. 1% as a decimal is 0.01. 1/4% is smaller than 1%, so its decimal better be smaller than 0.01. Going the other way, if I have a decimal, like 0.39, and I want to turn it into a percent, well, a decimal is sometimes called a proportion. It is implying that it's out of 1. It's 0.39 out of every 1 is what that proportion means. Well, percent is always out of 100, so we put it over 100. So to convert it, you have to multiply top and bottom by 100. So 0.39 times 100 is 39. So it's 39 out of 100, or 39%. Well, again, to make this conversion, we are always going to be multiplying by 100. And the shortcut for multiplying by 100 is just to move the decimal point 2 spots back to the right. So if I have 0.53, I simply move the decimal point 2 spots to the right. It is 53%. So once again, I'll just have you guys yell them out for me. 0.28 becomes what is a percent? 28%. Good. 0.6, 60%. Good. 2.9, 290%. 0.05 5/8. 5.8%. 7. Perfect. 700%. Good. So changing it from a decimal back to a percent is just as simple as going from a percent to a decimal. Going from a fraction into a percent is a little bit trickier. We'll start out with one that everybody knows. 3/4, of course, is what percent? 75. If we didn't know that, we would have a couple of options. We take our 3/4, we can convert it into a decimal by dividing. 3 divided by 4 is 0.75. And then move the decimal point to make it a percent. But not all fractions divide out that nice and neatly. We can look at 3/4 and think of it as 3 out of 4. A percent is always out of 100. If we want to find out what that number is, how much that is out of 100, we can do a process called cross multiplying. When you have two equal fractions or two equal ratios like this, the cross products must be the same. 3 times 100 is 300. 4 times x is 4x. So you get 4x equals 300, and you would solve that equation by dividing by 4. 300 divided by 4 is 75. So x equals 75. 75 out of 100 is 75%. We'll look at more complex percents, more complex proportions. Doing this full cross multiplication like this is usually more necessary than we solve the equation here. In a simple proportion like this, solving the equation is always going to be just dividing by this number that's on the diagonal with our variable. So we simplify that process. Rather than cross multiply and solving an equation, we just do cross multiply and divide. We multiply the two numbers that are on the diagonal together, 3 times 100 to get the 300. Then we take the number that's on the diagonal with our missing number, and we divide by it. Divide by 4. It gives us the 75. So 75 out of 100, or 75%. So if we have 7/8, we set that up as 7 over 8 equals how much out of 100? Cross multiply and divide, you get 87.5. So 87.5 out of 100, which is 87.5%. This concept here, this way of setting it up, actually leads us into how we solve our basic percent problems. Let's say we ask you to, let's just say blank is 30% of 90. To solve these problems, we always start with the percent, 30%, which is 30 out of 100. Now, on the other side of this proportion, we have to match numbers up. There are going to be two other numbers. We have the 90 here, and we have the missing number. One of them matches up with the 30. One of them matches up with the 100. Now, the 100 represents the whole thing, the whole population that we're looking at. Often it's referred to as a base. Sometimes it is the beginning amount or the initial amount. It is a starting amount or a basis for what we're doing. The 30 then is what's called a portion. It is a piece of that whole population that we are focusing on. So that we are trying to single out from the rest of it. So here it says blank is 30%. That means the blank or the missing number matches up with the 30. Of 90, you can read that as out of 90. Implies the 90 has to go on bottom. The 90 is the whole amount that we're trying to find a smaller piece of. So now we cross, multiply, and divide. 30 times 90 is 2,700. Divided by 100 is 27. So 27 is 30% of 90. We might have blank is 140% of 60. We're going to do the same thing. 140%. It's 140 out of 100. The of 60, we can read that as out of 60, implies the 60 has to go on bottom. And our missing number, of course, corresponds to 140. Now here the percent, the 140 is bigger than 100, which implies the piece we're focusing in on is actually bigger than the whole amount, more than the whole thing. So we cross multiply here, 140 times 60 is 8,400. Divided by 100 is 84. So 84 is 140% of 60. We get an amount bigger than the 60. This one here is worded quite differently, but it's really the same type of problem. 70% of 30 is blank. 70% is 70 out of 100. We can read of 30 again is out of 30. And so our missing number goes on top. Cross multiply and divide. 70 times 30 is 2,100. Divided by the 100 gives us 21. So in all of those, we were looking for the number that matched up with our percent. We're looking for that portion of it. We can have some that look like this. So here, 80% is 80 out of 100. But here we have 32 is 80%. The 32 matches up with the 80. We'll read this as out of blank. The missing number goes on bottom. Even though we're missing a different number, the calculation is still the same. We're going to cross multiply. 100 times 32 is 3,200. We're just cross multiplying in a different direction. Dividing by the 80 gives us 40. 32 is 80% of 40. Or we might have 20% of blank is 34. But here again, we have the percent. So it's 20% is 20 over 100. Of blank, we can read that as out of blank. Implies the missing numbers on bottom. 34 has to go on top. Cross multiply, 100 times 34 is 3,400. Divided by the 20 is 170. So 20% of 170 is 34. Any questions so far? Well, what if we have one like this then? $18 is blank percent of 30. So far, I've always started with the percent. But on this problem, I don't have the percent. Well, it really doesn't change anything. I'm still going to start with the percent. I'm just going to do blank over 100. Now here, 18 is blank percent. Implies the 18 goes with that missing percent. Of 30, again, you can read that as out of 30. Implies the 30 goes on bottom. So we can cross multiply and divide. 100 times 18 is 1,800. Divided by the 30 is 60. So 18 is 60% of 30. Or we might have blank percent of 90 is 45. Well, same thing. We're missing the percent, but we're still going to start with it. Blank percent is blank out of 100. of 90 can be read as out of 90. Implies the 90 will go on bottom. Is 45, so the 45 is on top. And we'll cross multiply and divide to find our missing percent. 100 times 45 is 4,500. Divided by 90 is 50. 50% of 90 is 45. Now, I like using this proportion because you can see sometimes we're cross-multiplying one way, sometimes another, but it's always cross-multiply and divide as our calculation. Some of you may have been taught something called the rate method of percents. I know it was the way I was taught. And in the rate method, what you're taught to do is take your percent and change it to a decimal. So 30% becomes 0.3. And now for this problem, it would be the 90 times 0.3 is 27, which is our answer. Or even this one, 140 is 1.4. So it would be 60 times 1.4 is 84, which is our answer. Which seems a lot simpler. The problem with the rate method is, if I drop down to one like this, 80% is 0.8 as a decimal, but it's not 32 times 0.8, it's 32 divided by 0.8 to get 40. Same here, 20% is 0.2, it's 34 divided by 0.2 to get 170. So with the rate method, you have to be able to figure out whether you're going to multiply or divide, or even like this one, there is no percent. So it's 18 divided by 30 is 0.6. Then you move the decimal point to make it 60%. So I like the proportion method here because once you get the numbers in the proportion, it's always cross multiply and divide. Always the same calculation. There is no trying to decide, do I multiply, do I divide? Do I divide it and then move the decimal point later? It's always the same calculation. Now there are applications that we will run into where this rate method is much easier. If we're talking about calculating interest, calculating commissions, stuff like that, that rate method is easier. And we will see some applications next time we do percents in the next unit where that rate method is useful. Okay. Next thing we want to look at here with our percents is some basic story problems. And let's just do a couple of simple ones here. Let's say PDM Corp estimates monthly profit as 12% of gross sales. What were the gross sales in a month where profit is estimated at $49,680. Well, we have a percent here, 12%. So 12% is 12 out of 100. Now with word problems, I like to label stuff. So that 12 out of that percent represents a piece that we're looking at. The 100 represents a whole amount or something we're basing it off of. So the 12%, the 12 represents what here? Profit. And the profit is being calculated as a piece of what larger number? Of the gross sales. So the 100 represents the gross sales. Now when I set up the other side of this proportion, I have to make sure those numbers match up. So we're asked, what were the gross sales? So we're looking for this number on a month where the profit is estimated at $49,680. $49,680 has to go with the profit. That has to be on top. So now we can cross multiply and divide. 100 times 49,680 divided by 12 is going to be, what's that? 414,000. Very good. So $414,000. Another reason why I like using the proportions for my percents, in word problems like this, the proportions, as long as you keep them labeled, they help you get the numbers in the right place. Now there are problems we run into that are going to be a little more difficult, and we're going to look at more of these again in the next section. But we might run into problems like this. Pat pays 30% of the gross pay in taxes. How much does Pat take home in a week where gross pay is good. $2,300. So we've got the 30% here. The 30 represents what in this problem? Well, 30% of gross pay implies the gross pay is the larger amount that they're taking out of. So that would be the 100. The piece of the gross pay that the 30% focuses in on is taxes. 30% of the gross pay is taxes, is in taxes. So now, does the problem tell us either the taxes or the gross pay? Tells us the gross pay, so that's got to go down here. We cross multiply and divide. 30 times 2,300 divided by 100 is $690. Now, before we do anything more, we have to ask, is that what the question is asking for? Is it asking for the amount of Pat's taxes? It's asking for what Pat takes home, which is the amount after taxes. So even though we did the percent correctly, we're still not done with the problem. We still have to subtract that percentage, the taxes, from the whole amount to get $1,610 is what Pat takes home after the taxes. Any questions? Okay, as I said, we may come back even at the end of the hour today and do a little bit more of those, but we will definitely come back in the next unit and do more with percents. We'll look at some basic interest and stuff. I want to get to our last topic just to make sure we've got enough time. Some groups take a little longer on this, some groups don't. All depends on where you're at in school. Some schools don't teach this anymore. We want to look at Roman numerals. The Roman numbering system, Roman numeral system, is much different from our system. It's not a place value system. The place values is only relevant compared to its location to other symbols, not its absolute location within the number. Roman numerals are still used quite a bit for like copyrights. If you look inside a book, you'll say copyright, and it'll have a Roman numeral. It actually gives you the copyright date in a lot of them. Some of our medications are still prescribed in Roman numerals, especially if you prescribe a medication in grains. They'll a lot of times do it in Roman numerals. So the first thing we want to do is we want to look at our Arabic numerals. Our standard numbers are called Arabic numerals, and its Roman numeral equivalent. So our number 1 would be the Roman numeral I. Now, when I was taught Roman numerals, I was taught you should always do them in capitals. The main reason for that was typewriters, the fonts were kind of funny. A small L and a 1 were indistinguishable on old typewriters. Now with some of the modern fonts, you can tell the difference between an L and a small 1. So it is okay to use small letters now for Roman numerals. So they can use a small I for a 1. Our number 5 is a V, again, either capital or small v. Our number 10 is represented by an X, again, capital or small. 50 is represented by an L, or of course a little l. Up to 100 is a C. If you ever hear the term a C note, that's where that comes from, a $100 bill. We jump up to 500, which is D. Again, you could use a small d, but I'm not going to write them down. 1,000, which is M. And that's as far as the Roman numerals go. To get any larger than that, they actually use a bar system. A bar actually means adding 3 zeros to it, or whatever. So like a V with a bar over it is 5,000. A 10 with a bar over it is 10,000, and so on. We're not going to get into that because we don't need to do anything that's quite that large. There is a symbol that many of us did not see if we learned these in high school or before. 1/2 is the Roman numeral SS. Stands for 1/2. Now in the Roman numeral system, it's an additive system. So if I want to express the number 2 in Roman numerals, I just put a 1 and a 1, makes 2. We're adding those together. The exception is we don't like to have more than 3. Well, they don't allow more than 3 of the same digit in a row. So like expressing the number 3 is I. That's perfectly fine. 1 plus 1 plus 1. But the number 4, which you would think would be 4 ones, they don't like to do it that way. Instead, they define subtraction within their digits. If a symbol for a smaller number appears before the symbol for a larger number, it is subtraction. So IV, since this is a 1 and this is a 5, the smaller symbol appears before the larger symbol. That really means 5 minus 1, which is 4. In the Roman numerals, they tend to only use subtraction with the 1 that we saw, the 10s, the 100s. They don't subtract the 5s or the 50s. I don't know why. It would make more sense in many cases if they did. So like if they want to do the Roman numeral for 45, again, to me it would make sense that you would just do 5 away from 50. 50 minus 5. Or VL. But they don't do it that way. They do XL, which is 50 minus 10, and then the V on the end. So they only subtract ones, tens, and hundreds. So let's convert some of our standard numbers, our Arabic numbers, into Roman numerals. Let's say we have 387. You always start with the larger place values. 300s. Can I express that by adding symbols together? Yeah. 100 is C. 3 C's is 300. If it had been 400, I'd have to do something different. 80. Well, that's bigger than 5, so I'm going to start out by expressing the 5, or the 50, which is L. How much is left out of the 80 now? I used 50, there's 30 left, right? Can I express that by adding together? Yes, I can. Just 3 X's would add up to 30. So we've expressed the 80. The 7. Again, that's bigger than 5. So I'll express the 5, which is just a V. What's left is only 2 more. So that's I and I. So that was one that I could express all with addition. I didn't need to do any subtraction in that one. Any questions on expressing that in Roman numerals? Excuse me. We might have 498. The 400, well, I can't add 400s together. I can't have 4 in a row. So the 400 is going to be expressed as 500 minus 100. So it's going to be C, D. Since the C is a 100 and the D is a 500, that's implying we subtract it. For the 90, same thing. I could do a 50, but it would be a 50 plus 4 tens. So rather than doing a 50 plus 4 tens, we do 100 minus 10 to get 90. So it's X, C. That expresses the 90. For the 8, can we express that by adding, or do we have to use subtracting? Now we can do adding, just a 5 and 3 ones. Like that. Any questions? I'm going to have you guys try one. $749. I'm going to give you a minute in your notes to try to express that in Roman numerals. Kind of like putting together a puzzle, isn't it? So now for the 700s, can we express that by adding, or do we have to subtract? You can do that as adding. That's 500 plus 100 plus 100. So 500 is D, C, C. 40. Can we express that with adding, or do we have to subtract? Subtract. It is XL. That's 50 minus 10, or 10 from 50, was the technical way they'd say it. That gives us the 40. Now for the 9. It's 1 from 10. 10 minus 1, or IX. Now I get asked a lot, why don't we do 49 as just IL, 1 from 50? Again, they tend not to do it that way. They tend to go digit by digit as they express them. So 49 is XLIX. Someday when I rule the world and I invent my own Roman numeral system, I'll make it more simple, but for now, we're going to live by their rules. More important for us is being able to convert the Roman numerals back into our standard Arabic numerals. So we might have CMLXXIX. So to convert these Roman numerals into our numerals, into standard numerals, we first have to look at each digit, and before we convert a digit, we have to look at the digit after it. So C means 100. What's M mean? 1,000. Now, since this is a smaller digit before a larger digit, I'm going to combine the two of them by subtracting. What's 1,000 minus 100? That's 900. L means 50. I look at the next one, that's a 10. So that one's larger, the L is larger than the one after it, so I'm just going to put down the 50. I look at the 10, the next digit's also a 10, so I can put down this 10. Here's a 10, it's followed by I is 1, so I can put down this 10. The next digit is smaller than it. This is a 1 followed by X is 10. So that's a smaller digit followed by a larger one. I have to combine the two of them to make what? 9. So that's 979 is what that's saying. So for this one, M is 1,000, C is 100. So I'm okay to put down the M. The digit that follows it is smaller than it. So I got to look at the next one. M is 1,000 again. That means, of course, I have to combine those two, because the next digit is larger. So C and M combined to make 900. 1,000 minus 100. X is 10. C is 100. So that means I'm combining those two to make 90. I is 1. X is 10. So I have to combine those two to make 9. That is 1999. Any questions? Okay, I'm going to have you guys try one. Give that one a shot in your notes quick. So again, we go digit by digit. M is 1,000. Well, the next M is also 1,000. So that digit that follows it is not bigger, so I can go ahead and put down the first 1,000. Look at the next digit here, X is 10, so I can put down that second M is 1,000. So I got the 10 for X. C is 100. So I have to combine those two digits. 10 from 100 is 90. L is 50. I is 1, so I can go ahead and put down the 50 for the L. One in X is 10, so that's 9. So 9, 42, 2,149. That's actually very sloppy Roman numerals, but it works. How many of you got 2,149? Okay, good. I should never have an L after an XC like that. You would never want to add 50 to 90 like that. So that was my mistake. what's going to be more important for you guys is going to be something that looks like this. So, I, of course, is 1. V is 5. So that means it's going to be taking 1 from 5. This is 4. And the SS means a half. Most often when they use Roman numerals in prescribing medication or specifying medication amounts, they put the label, the unit, in front of it. Like if they wanted to say 4.5 milliliters, we would write it like this. If they did Roman numerals, they would say ML/IVSS. Seems kind of backwards, but that's how they tend to write it out. So how about IIISS? Yep. It's 3 ones and a half. So 3.5. So MGIXSS would be, well, I is 1, X is 10, so that's 9, and SS is a half. So you've got 9.5 milligrams. I'm not going to get into doing operations with Roman numerals with you guys, adding, subtracting. It's really kind of an ugly process anyway. And it's not that important for you guys to do. Most of what you guys do, you'll never really need to be able to read a Roman numeral much bigger than 100 anyway, because they don't tend not to use them for dosages bigger than 100. And it is fading in the industry as time goes on. The number of people that use Roman numerals is slowly declining, which is a good thing. That is all of the new material for Unit 1. So as I said, that means starting off next week, the first hour of class will be the Unit 1 test. I will answer questions at the beginning of the class if you guys do have any questions on the homework that you want me to go over. You do have homework. Page 23 is the order of operations, 1 through 21, the odds. Page 36 through 37, this is on the percents, 1 through 51, the odds. Mostly on this test for the percents, we're concerned about being able to convert between the percents, fractions, and decimals, and then doing the very simple percent calculations. And then for the Roman numerals, it's page 39, 1 through 12. Any questions? Okay, so I will send out the tests probably about Wednesday or Thursday next week. I'll send them out to each site. For those of you in Richmond, they usually will either bring them in when they set up the TV in the morning for you. So either somebody will bring them into class and give it to you before class, or they'll be sitting in a folder up on the front desk somewhere and you can get them out of the folder. And then when you're done, you just put them back in the folder. If you guys want to come in earlier and start, if you're worried about having enough time, those of you in Rice Lake here, I am normally here before 8 o'clock if you want to come in a little early and start. In New Richmond, you can do the same thing, come in early and start. We will start lecturing on new material at 9:30 next week. Okay, well, you guys have a great week.